Dear students, today we can discuss about Newton's laws of motion and some problematic situations. For your coming entrance exam, this chapter become very important. For NEET exam, we can wait 3 questions. For JEE Main 2 and for KEAM entrance, maybe more than 4 questions. Newton's first law. You know, every object maintains its state of rest or of uniform motion along a straight line unless acted on by an external force. You must think about the terms inertia, inertia of rest, inertia of motion, inertia of direction. So simple concept, but keep in mind the frame of reference in which the first law is valid. That means the frame of reference which moves with the constant velocity or rest is called inertial frames. Otherwise, they are called non-inertial frames, means accelerated frame of reference. We can go with one good question. A block of mass is suspended by a cord A from the ceiling and another cord B attached to the bottom of the block as shown in figure. Which string will break if we pull the string B with a sudden jerk and steadily? Look at the figure. The block connected to the ceiling with the A string and we are pulled with the B string. So this question we can solve only when you know the concept of inertia. Look the answer. Because of inertia of rest, the force will not be transmitted to the string A and the string B will break if we suddenly pull it. But when we pulled steadily, the force applied to it will be transmitted from B to A through the mass capital M, and hence the tension in A become greater compared to B. The string A will break. So you should know the difference between the two situations. The Newton's second law, the definition of force, the rate of change of momentum of a body is directly proportional to the force applied to it, as you know. We know the concept as F is equal to dp by dt. We can substitute for momentum as m into v. You can just differentiate. We are with the two terms, but they are used independently. Look the situation. If the mass m is constant, that's a situation for the normal cases. We know the dm by dt becomes 0, and hence we can use that m is equal to m into dv by dt or m into a. But if v is constant, we know dv by dt becomes 0. That means f becomes v into dm by dt. So it is applicable for the variable mass system. That means the rocket propulsion, conveyor belt, etc. We can go with different type of problems. Maybe a very important concept, the different usage of the second law. Look the question. A force F is equal to 6I minus 8J plus 10K Newton produces an acceleration of root 2 meter per second square in a body Then calculate the mass of the body. And you know it is a vector quantity. Its magnitude can be simply find out as equal to root of fx square plus fy square plus fz square. And here it is equal to root of 36 plus 64 plus 100. You get the value root 200. And we know the acceleration is nothing but the modulus of force by mass. And you get the answer. Look the different type of question. A block of metal weighing 2 kg is resting on a frictionless plane. It is struck by a jet releasing water at a rate of 1 kg per second and at a speed of 5 meters per second. Calculate the initial acceleration of the block. So maybe the good example for the variable mass system. And we already know the force is nothing but equal to V into dm by dt. It is given the velocity is nothing but 5. That the rate of water ejecting is dm by dt is given as 1. You get the value, the 5 into 1 equal to 5. So the acceleration becomes force by mass. So 5 by 2, you get the answer 2.5. And see the another concept of conveyor belt. Gravel is dropped into a conveyor belt at a rate of 0.5 kg per second. The extra force required in Newton to keep the belt moving at 2 meters per second is, you know, F is equal to V into dm by dt. So the velocity is 2 into 0.5 equal to 1 Newton. Look the next extra concept. The power of external force, that is equal to V square into dm by dt. The reason you know the power is nothing but equal to F into V. So very good questions. We can move to the another type of question regarding force. A force of 50 Newton acts in the direction as shown in the figure. The block of mass of 5 kg resting on a smooth horizontal surface. Find out the acceleration of the block. Look here, the force is acting at an angle 60 degree with respect to the vertical direction. We have to find what is the acceleration of the block, and that will move horizontally. So we have to take the horizontal component of force, and that force can be split into two components. So if it is 60, then this angle becomes 60. So this component becomes cos 60 and this becomes sin 60. So we can say that sin 60 takes the horizontal component, and hence we can write it as 50 into sin 60. So equal to 50 into root 3 by 2. So simply the acceleration along the horizontal direction is the component of force along horizontal division by mass. So 50 root 3 by 2 by 5. And we get the answer as 5 root 3. Another very good question. As shown in the figure A and B, two identical balls strike a rigid wall with equal speed but at different angle of incidence. They are reflected back without any loss in speed. Look the two figures. But here, if you just consider the figure A, the 180 degree deflection is happened. So we can just find the change in momentum is equal to m into v2 minus v1. The final direction is minus v and the initial direction is v. So you get the value as minus 2 mvi. Look the direction. But while considering this b, at first we can split that the initial v into two components, and similarly the final one can be split into two components. Then based on the vector algebra, the v1 and v2 can be written as the V1 as V cos theta I minus V sin theta j, and V2 equal to minus V cos theta I minus V sin theta j, then we can find the change in momentum is equal to m into change in velocity. So we get the answer minus 2 mv cos theta I. A good aspect, a good question, keep in mind. Another very important aspect, what do you mean by impulse? When a large force acts on a short interval of time and is called impulsive force, that is nothing but equal to f into dt or equal to the change in momentum, a pure vector quantity. We can go with the two situations. If the force is working between the time t1 to t2, we can written as the integral form integral t1 to t2 f dt. In terms of momentum, we can convert as if f dt is equal to dp, so the limits changes to p1 to p2. So the change in momentum is the impulse. If a constant or average force works on the body, again simple, f average into integral t1 to t2 dt. We are waiting with a very good question, a graphical approach. The figure shows the position time graph of one-dimensional motion of a body of mass 500 gram. What is the time interval between the two consecutive impulses received by the body? We have to find the time interval between two consecutive impulses received by the body. So look the figure. So here 0, 2, 4, 6, 8, 10, 12. The graph changes from positive to negative at 2 seconds and to negative to positive at 4 seconds, and so on. Thus the direction of velocity is reversed after every 2 seconds. Therefore the body receives impulses after every 2 seconds. Another question. A machine gun fires a bullet of 50 gram with velocity 1000 meter per second. If the average force acting on gun is 200 Newton, then find out the maximum number of bullets fired per minute. We know the force is the change in momentum by time, and we can written as the momentum as for n bullets as n mv by t. We have to find the number of bullets per second. N by t is equal to f by m into v. You get the answer as 4. But per second as 4. Then in 1 minute, it becomes 60 into 4. You get the answer 240. A good aspect. Again, a very good question. The figure shows an estimated force time graph for a baseball struck by a bat. From this curve, determine the impulse delivered to the ball, the average force exerted on the ball. We have to find what is the impulse and average force. Look at the figure here. The impulse is nothing but the area under that force time curve. The area is, it's a triangle, half into, base into that altitude. You get the answer. What do you mean by the average force? So that is nothing but equal to impulse division by time. So you get the answer as 9000 Newton. A good aspect, good concept. The law of conservation of linear momentum. We can go with a lot of examples in the coming chapters. You know, if there is no external force acting on the body, then F becomes 0. That means dp by dt becomes 0. The momentum is constant. The momentum is constant before the event is equal to after the event. A good example, the recoil of the gun. That small bullet moves a lot, but the heavier rifle or gun moves a small distance. But we know the before and after the momentum is conserved, in the sense we can written as before 0, after 0. So after 0 equal to capital M into V for the gun plus M into V for the bullet. So we can find the recoil velocity, but keep in mind it got the opposite direction to the velocity of the bullet. The third law may have the chance for misconceptions. So it's a very important concept. For every action, there is an equal and opposite reaction. When two bodies exert mutual forces on another, the two forces are always equal in magnitude but opposite in direction. And keep in mind, a single isolated force is physically impossible. The action and reaction never act on the same body, but always on different bodies. If they act on the same body, the body will be in equilibrium. So there is a concept. So keep in mind. A very good application is waiting, the rocket propulsion. We can just go through some relations. If m0, the total mass of the rocket at rest, after a time t, the mass of the rocket is m and its instantaneous velocity is v. We can go with some different situations. In gravity free space, g becomes 0. The f is equal to vr into dm by dt. If gravity is considered, we can say m into dv by dt is equal to vr dm by dt minus mg. So we can easily find the dv by dt or acceleration as vr by the present mass into dm by dt minus g. The very important two situations. The instantaneous velocity after a time t is equal to v0, the initial velocity, plus vr log m0 by m minus dt. If the fuel is completely burned, then the remaining mass becomes the mass of the container. We can express that velocity is equal to v0 plus vr log m0 by mv. A good problem is waiting. A rocket of initial mass 6,000 kg eject mass at a constant rate of 16 kg per second with a constant relative speed of 11 km per second. What is the acceleration of the rocket a minute after the blast? We already know the relations. If gravity is neglected, we can written as Vr by m into dm by dt. You should know what is m. That is m0 minus mt after a time t, mt. So all the details are given here. So you just substitute, you get the answer as a 34.92. We can written as the 4 as the answer. A very important concept. Very important concept. The free body diagram. The diagram to show all the external forces acting on an object. Look the figure. The three blocks of masses m1 and m1, m2, m3 are placed one over the other as shown in figure. Draw the free diagrams of all the three blocks. Look the figure. Look the free body diagrams. Look here m1. Its weight is acting vertically. So that m2 will give a reaction. That is NAB. Look m2. The weight is acting vertically. But because of m1, because of NAB, m1 will give a reaction. And m3 will give another one. That is NBC. And similarly for m3. Weight, the m2 will give a reaction and the ground will give another. Look, NAB, the normal reaction between A and B. NBC, the normal reaction between B and C. NCG, the normal reaction between C and ground. So this concept is very, very important. We can go through a lot of problems in the next video. So it is a very important concept, our psychological perception, the apparent weight. And keep in mind, the apparent weight is nothing but the reaction of the supporting surface. The weight of a body in a lift. So we can go through the different aspects. The first one, the lift is at rest or moving with constant velocity. That means the reaction is nothing but the weight. So the apparent weight becomes the weight itself. There is no change. But if lift is accelerated upward, so the net force is acting upward. But we know the weight is there, the reaction is upward. So we can written as that R1 minus mg, that is equal to ma. And hence we get the value R1 equal to m into j plus a. We know the apparent weight is the reaction of the supporting surface. The apparent weight increases. But there is a chance for another one. If there is a negative acceleration, then what happens? That apparent weight should decrease. The formula becomes m into g minus e. A very important concept. What happens if lift is accelerated down? You know the net force ma is acting vertically downward. That means mg minus r2 should equal to ma. You get the value r2 equal to m into g minus a. Surely we can say the apparent weight decreases. But there is another situation. Keep in mind. What happens if a becomes minus? The weight increases. That is a special case. Then the fourth point, if the lift is under free fall or inside a satellite or for the projectile motion, even though there is gravity presence, keep in mind the apparent weight is zero. Another extra concept, the weight of a body in a liquid. That is m0g into 1 minus sigma by rho. If the body is under floating, the apparent weight becomes zero. We are waiting with a very good concept. With what minimum acceleration can a fireman slide down a rope whose braking strength is given as 2/5 of his weight? You can just return. The maximum tension affordable should be greater than or equal to 2 by mg. So m into g minus a is 2 by 5 mg. So minus ma, that should be greater than 2 by 5 mg minus mg. So you get the value a equal to 0.6 g. The translator equilibrium, that means the net linear force acting on the body becomes zero. You just think about the Lami's theorem, a very good application. If there are three concurrent forces acting on a particular body, if the resultant becomes zero, then we can say the Lami's theorem means the force by their sine component of the angle, opposite angle. So F1 by the opposite angle sine theta 1 equal to F2, the opposite angle sine theta 2 equal to F3 by sine of the opposite angle theta 3. A good question. A mass of 80 kg is supported by two cables as shown in the figure. Find the ratio T1 by T2. So look the figure. Yes, here 60 degree, here 30 degree. This part become 90 and hence we can find this angle. So that is 30 degree, 30 degree, 30 degree. That means this angle is what? The total is 180, 180 minus 30, 150. Already this is 60. So 60 minus 180, it becomes 120. So you can just apply our Lami's theorem. So can be written as T1 by sine 120 equal to T2 by sine 150 is equal to, on bottom 18 to 10 by the sine 90. You get the value. We are waiting a very, very important concept in the pseudo force. It is a fictitious force used to explain the motion of objects in non-inertial frames, accelerated frames, and this force always works in the direction opposite to the acceleration of the frame. Look the figure. So here there is no motion, but it is acceleration. So that bow moves in the backward direction. We are with a good question. A pendulum of mass m is suspended from the ceiling of a train, moving with an acceleration as shown in figure. Find the angle theta in equilibrium position and tension produced in the string. You know the weight, the pseudo force, the tension can be split into two components. We can balance. We get the value tan theta equal to A by G. The tension can be written as simply is the product of these two, the resultant of MA and MG. You get the value. But keep in mind that M is applicable only when for an observer inside the train, not for an outsider. An interesting question is waiting. A vessel containing water moving with a retardation towards the right along a straight path, which of the following diagram represent the surface of the liquid? So it is going towards the rightward but retardation. So the braking force is applied. Braking force is applied. As inside a vehicle the passengers are moving forward, the surface of liquid should move in the upward direction. So you get the answer as a C. So keep in mind, it's a very important chapter. So we can discuss the very important problems with the connected systems and friction in the coming video. So God bless you. Take care.